Hey everyone, welcome back to your channel Technology Incredible. Today we will see problem number 823, that is binary trees with factors. Okay, so this is a lead code medium level problems. Let's check out the problem. We have been given an array of unique integers ARR. All the integers in the array are unique and each integer is strictly greater than 1. Okay, so all the integers, all the elements in the array are greater than 1. We make a binary tree using these integers. Okay, we have to make the binary trees from these integers, and each number may be used for any number of time. We can repeatedly use the numbers. Okay, each non-leaf node value should be equal to the product of value of its children. Okay, each parent should be equal to the product of its child. Okay, like this. If 10 is the parent, then what are the child nodes possible? 2 and 5, because 2 into 5 equals to 10, like this. 5 and 2, this is also allowed. 5 into 2 equals to 10, this is also allowed. They have said that we can repeat the number. 2 into 2 equals to 4, this is also allowed. That parent node should be equals to the product of child node. These are the conditions. Okay, let's see. They have given some examples. First example is that they have given an array ARR in which the elements are 2 and 4 and the output is 3. How the output is 3? They have given the combinations also for the binary tree. The first is 2. Okay, 2 individually makes a binary tree. Then 4 can also make, and the next is 4, 2, comma 2. Like this, that if 2 and 4, 2 and 4 is the array. Okay, this is the array. Then what are the possibilities? That 2 is the binary tree with null as nodes. Okay, the leaf nodes are null, child nodes are null, so this is allowed. Next is 4, like this only. 4 is also a binary tree. Okay, the next is 2. We can repeat the number, so 2 and 2, this is also a binary tree. So like this, there are first, second and third. 3, now we have to return 3 for this array. Next example they have given is the array is 2, 4, 5, 10, and the possibilities are 7. That is, there are 7 possible binary trees from this array. Okay, 2, 4, 5, 10. So 2 can be individually a binary tree, like this. 4, 5, 10. Okay, so 2, 4, 5, 10 with null nodes as their child nodes. Okay, now next is 4, 2, comma 2. We can repeat the number. So 4, 2, comma 2 is a binary tree. Then 10, 2, comma 5 and 10, 5, comma 2, like this. Next example they have given is 2, 4, 5, 10. Okay, let's see, we will see it. 2, 4, 5 and 10. So first is 2 with null node. Okay, like this. 4 also, 5 also, 10 also, like this. 4 are covered from these 4 elements. Now for 4 we can repeat the number. So 2 comma 2, 4, 2, 2. Okay, now for 5 there is only one possibility. Okay, now for 10, 2 comma 5 and 10, 5, 2. Okay, these are the possibilities. So 1, 2, 3, 4, 5, 6 and 7. So 7 binary trees are possible with these numbers. So let's take an example. You will understand that how we'll find this number, the possible binary trees numbers from dynamic programming approach. Okay, so we will make a dictionary, a map like structure, and each number is mapped with a value, that is the number in array are the keys and the value will be the number of possible combinations. So what we will do, we will initialize this uh, values as 1. Why 1 we are initializing the value? Because we know that there for each number there is one possibility, okay, with this null node. This is confirmed. For each number we have possibility of one binary tree at least. Okay, so we have initialized this structure with 1 as value initially. Okay, so like this, how this will be mapped, that like this 2 will be mapped to this, okay, this index. So 0, 1, 2, 3, 4, 5 and 6, like this. These are the indexes. Okay, let's solve it. Now we start iterating. From where we will start iterating? From 2 we will start iterating. So 2 is the first element, so index is 0. So first thing we have, what we can do is we have to sort the array. Why we are sorting? Because as we know that the parent node is always greater than child node. Why it is greater than child node? Because parent node is equals to the product of child node. If child node is 2 and 2, then how can the parent node is less than 2? Okay, parent node should be greater than 2 only. If one of the child node is 2, then the parent node should be greater than 2. It can't be less than 2. So that's why we have first sorted the array. Okay, so after sorting, what we have noticed that we have to iterate less. Now we start iterating from 2. As 2 is the first element and there is no element less than 2, so there is only one possibility for 2 as binary tree, that is 2 with null node at its child nodes. Okay, now what we will do, we will increment the I count. I will become 1 now, and the previous element we are iterating from j equals to 0 to j equals to I minus 1, like this. This will be a j range. Okay, this will be a j range. So next 4 will be our parent node. Then we have to find the number of possibility for its child combinations. So first element within j range is 2. So what we will check, that if 4 modulo 2 is 0, if this returns true, then what we observe, that 4 is divisible by 2, and if 4 is divisible by 2, then there is possibility of getting the product as 4. Okay, so we will find the other element between this range only. As we can repeat the number, so we will check, we will cover this 2 again. Okay, so 2 comma 2, this product will give 4. So for 4 we have found one more combination from 2. Okay, so what are the number of possibilities for getting 2 is 1. So we will increment this value as 2. Now it will become 2. Now we will increment our I pointer, and now I will become, okay, now I became 2. What we will do, we will check same what we have done for the previous. Okay, j0 to I minus 1, j0 to I minus 1, I minus 1 will be 1. So 6 as the parent node, we have to find the child nodes. Now j0, if 2 is the element, 6 modulo 2 is 0. Yes, 6 is divisible by 2. So 6 modulo 2 is 0. This will return true. So what we will find out, that 6 divided by 2 is 3. So we need 3 at this place. So do we have 3 in this range? No, we don't have 3. Okay, as we don't have 3, so this is not possible. Okay, now next we will check for 4. If 6 is the parent node and 4 is one of the child, then 6 modulo 4 is 0. Is 6 modulo 4 is 0? No, it is not 0, because 6 is not divisible by 4, so it will return 4. So a value for 6, there is only one possibility for 6 is that 6 with the child node as null. Okay, no possibility for no any other possibility other than that. Then what we will do, we will increment our I value. Now I will become 3. Okay, now I will become 3 and it will move to 8. I will become 3 and j will be from 0 to 2. So what we will do, our parent node will become 8 and we have to find the combination for child nodes. Now first j is 0, we will tick 2. Now 8 modulo 2 will be 4. 8 modulo 2 is 0. Okay, 8 modulo 2 is 0. It means that 8 is divisible by 2. So we have possibility of getting. Now we will check what the other number we need. 8 by 2 we will do. It will be equals to 4. So 8 by 2 we need 4 at this place. Now what we will do? We will check that is there any possibility between these range to that we get 4. Yes, there is possibility, and at the first index we have 4. So in how many ways we can get 4? In 2 ways. Okay, so at this index 0 1 2 3, at the third index what we will do, plus 2, because possibility of getting 4 is 2. Okay, one is 2 into 2 and one is 4 only. Okay, so this will become 3. Now our I pointer will move forward. Okay, I will become this for 10. Now 10 modulo 2 is 5. Okay, 10 modulo 2 is 0 because remainder is 0. Then we will find the 10 by 2. 10 by 2 will be 5. 10 by 2 is 5. Now what we need? We need one element is 2, other element we need 5, but we don't have 5, so we'll discard this option. Now what we will do? We will do j plus 1. If now 10 modulo 4, is 10 is divisible by 4? No, 10 is not divisible by 4, so we have to discard this option also. Is 10 is divisible by 6? No, 10 is not divisible by 6, so we can discard this option also. Okay, like this. So for the 10 on also we have only one possibility and we have only values till fifth index. Okay, this I have added extra. Now at the last index 12, what we will do? Just understand this. This is the last and you will understand. Our parent node is 12. We have to find the child nodes. Now what are the possibilities of from where we can find child? From this 0 to I minus 1. This is the range of for j. Okay, this is the range for j. Now first j will be 0, so value will at 0 will be 2. Now we will find that is 12 is divisible by 2. Yes, 12 is divisible by 2. Remainder will be 0. So what we will do? 12 by 2. 12 by 2 is 6. We need 6 at this place. So what we will check that do we have 6 between this range? Yes, we have 6. And what are the possibility of getting 6? Is 1. Okay, so what we will do, possibility of getting 2 is 1 and possibility of getting 6 is 1, so it will be 1. So one possibility is 3, this. Okay, now like this we will iterate. The next possibility will be 6 at this place and 6 at 2 at this place. Okay, 6 and 6 2. So like this there are two possibilities for this. So we will add 2 here. Now how many possibilities total? What we will retain? We will retain the sum of this array. We will retain the sum of this BP array what we have created. Okay. So 1 plus 1 plus 2 plus 1 plus 3 plus 1 plus 3. Okay, these are the possibilities: 3, 6, 7, 8, 9, 10, 11. So there are 11 binary trees are possible. So I have defined this problem in 4 steps. Like how can we solve this problem? So let's say first what we have done, we have sorted the array. Okay, so we have to iterate less. Now second, what we can do, we can do a we can create a default map or dictionary. Like this, we are creating with default value as 1 because there is one possibility for each element, as the leaf element, the child element is the null. Okay, null as the child element. So we have initialized the default values as 1. Now what we will do, we will iterate for all these elements. Now for 2, okay, we are iterating 2. Now what it become? For 2, there is no element less than this, so it will remain 1 only. Now for 4, uh, there is possibility 2 into 2. Okay, that is a one element 2, and which is divisible by 2, and we get we can repeat the number. So 4, 2 into, this is the possibility. So we will add 1 here. Okay, the value will become, for 4 value will become 2. Now next element as parent element is 5. Now is there any possibility, any number which is divisible by 5 here less than this I value? No. So it will remain 1 only. Now next element is 10. 10 as parent element. So 10 as parent element. Is there any possible combination? 2 by 10 is 5. Okay, so 2 can be the one element. And what we need 5, but 5 is available here. So there is one possibility. Like this, if 5 is the first element, then what we need, one more element as 2, and 2 is also available here. So like this, 2 more possibilities for 10. So the answer will be 1 plus 2, 3, 4, 5, 6, 7. Like this, there are 7 possible binary trees for this array. Now let's say this is example only they have taken. They have written the value as 7. Now let's check out the code I have written in Python. First, what I said, that we have to sort the array. So I have sorted the array dot sort. Now the value can be very much greater, so they have said that we have to return the mod value, modulo 10 power 9 plus 7. So we will return the this, we will at the end we will divide the value by mod. So we have initialized the value of mod as 10 power 9 plus 7. Now we have initialized this default dictionary. Now every element in array, okay, every element num in array will be the key, and the value will be 1. This is initializing the default values as 1. This. Now next is we are iterating for the array. Okay, we are iterating 2, 4, 5, 10. Then for each range in 0 to I, we are like this. If we are checking for 5 as parent element, then we are checking the child element between this 2 comma 4. So like this. Now what we are, first we are checking that is it is divisible by, the remainder is 0. If remainder is 0, then not of 0 will be 1, and this condition will become true. Okay, now what we will find, that is number divided by array of j is this, if 10 by 2. Okay, 10 by 2 is 5. What we will check, that is 5 is available between this range. If it is available, then we will add the combination in a dp dictionary. Okay, we will add the possibility, and for valid answer we divide it by the mod value, because the value can be too large. So at the end we are returning the value of this sum of this values, this value 7. Okay, like this your all the test cases will get passed. Thank you.